I guess now in last class we have studied on this concept that we have taken four parallel plates having same surface area and same separations between them. Accordingly, we have discussed one concept in previous class. Now here we will discuss three more concepts with you. So you just suppose this one is second question. Again we have taken four plates with same separation. Now here I want to connect this one together and the middle two ones we have taken as a terminal. Then you have to find equivalent capacitance of the three capacitors. You are seeing that if four plates be there, then your capacitor will be one less. So that is 1, 2 and 3. There are three capacitors are there. So in same manner, you have to take just this one is as a capacitor. So you just draw there is a capacitor 1 having capacitance C, and this capacitor makes as a terminal. So this one is terminal A and let it be terminal B. Now what's going to be there that from this capacitor second plate is also connected with one capacitor, because there is one more capacitor. So you just draw from here, there is one more capacitor like that. So there is one more capacitor, and now from this capacitor second plate we connected from one more capacitor, which one is connected from first plate. So you just draw one more capacitor from here, and the second plate and this one is also second plate, both are connected together. So you just get connected with this one. So from here you see that there are three capacitors are connected in this way. So what you are saying that this C and this C. So this C and this C be connected together as a series combination, and thus the equivalent of this one be connected from this capacitor in parallel. So accordingly, because this one and this one is in series, so for series combination, in series combination this one is connected like that. 1 by Cs for series is equal to 1 by C1, that is C, plus 1 by C1, that C2, that is C. So what will be there? This one will be 2 by C. So your Cs for series combination you will get C by 2. So this one is equation 1. Now so your equivalent circuit that will be like that one capacitor be there, this one is Cs, and one more capacitor, this one. So this one is C, and then there is terminal A and terminal B, where CSB C by 2. So this CSB C by 2. Now both are in parallel, so parallel is directly connected as an algebraic sum. So you just take it that your CP, if parallel, this one is C1 plus C2. So your C1 is CS and your C2 is C. Now put the value of CS from this equation 1. So what you will get? C by 2 plus C. So accordingly your CP, so this CP will be, now after being calculation, 1 plus half is 3 by 2. So that will be 3 by 2 of C, and this is your answer. So you can solve this kind of questions like that. But for solving this one, you need to keep in your mind that every space be a capacitor. Now when I am going to take a combination like that. So this one is one more combination. I am just doing going to suppose that this one is terminal A and you just suppose to terminal B, whereas you have three capacitors 1, 2, 3. Now here's draw an equivalent diagram of the circuit. So you're seeing that there is one capacitor, so you just take that there is one capacitor. From this one another capacitor be connected, so you just connect one another capacitor, and from here you have to take one more capacitor. But how you can connect this one? Before that, you just connect that this capacitor having first terminal and this one having this one is second terminal. Just leave it second capacitor and having second terminal. You just connect these two together like this. Like this, you just connect this one, and this one is your terminal A. Accordingly, from here you just connect one more capacitor like that. So you just connect from here one more capacitor, and its second terminal be connected from the second plate of the first capacitor, that is from here like that. And you are seeing this one is your another terminal, that is terminal B. So how it is connected? You are seeing that from this one, the second of this one is connected together. Also this one is connected together, and all one terminal is connected together. That means whenever you will think, so this one is like that. This one is like that. You are seeing that. This one is your terminal A and this one is your terminal B. That means what's be going there, that all your capacitors are connected in series. Are connected in parallel. So if all capacitors B are connected in parallel, so for parallel your CP will be is that will algebraic sum. And your algebraic sum is C1, that is C plus C2, that is C plus C3, that is C. So accordingly your equivalent capacitor for parallel combination be 3C, and this is your result. Now we'll take one more example, like question number 4. In this section, what we will do, we will just take one terminal be there, that is this one is A and this one is B, whereas these two plates are connected together but there is no terminal. Then again, by same process we will go there. We just take this one as a one capacitor. So we just draw here, there is one capacitor, but what is be there? There is one terminal. So you just take it terminal A, and from this one another condenser be connected, that is one another capacitor be connected, and its second plate, this one, is taken as terminal B. And what's going, that its first plate from here and its second plate, that is from here you have to take one more capacitor like that, and you have to connect this together, and you just make it in this connection, whereas you have this kind of terminal A and terminal B. Then now you just analyze this one, that what's going to be there. You just see that from this terminal here there is a node. From this node, what's happening, two capacitors are there, and these two capacitors right now connected together. You're seeing there that this one is connected together, right? And then from this node one capacitor be connected, and that gives from its second plate a terminal B. So what you will see, that both are connected in parallel. So you just draw and equivalent capacitors for this parallel combination. So simply for this parallel, C1 that is C and C1 that is C, that is 2C. Just make it equation 1. So your equivalent capacitor, equivalent diagram will be there, that there is one capacitor and one terminal, second capacitor and your second terminal. This one is combination of these two, that is CP, and this one is C. Simple, because everyone is C. Okay. So now you're seeing that both are is connected in series. So for series combination, you know its combination is just like taken in reverse. That 1 by Cs is equal to 1 by C1, that is Cp, plus 1 by C2, that is C. Now after doing calculation, you will see that from here there is C, Cp, and there is C plus Cp, and then this one is 1 by Cs. It's simple. So your Cs, that would be C Cp divided by C plus Cp, and then now put the value after doing. So your Cs, that would be C Cp. C is C. How much is Cp? So your Cp from this equation 1 is 2C. So there is 2C into 2C, and then divided by C plus 2C. So C plus 2C. So how much will be there? C will be cancelled. So 2C divided by 2 plus 1, 3. So your Cs will be 2C by 3, and this is your result.